Here's the problem where we're going 36 miles per hour for the first half of the trip, how fast for the second half, to average 45 miles per hour for the whole trip. Now, you may have already seen, or we may have already gone over, that we can't simply average the speeds in order to get the average speed, which sounds a bit contradictory. We can't average the speeds to get the average speed, but you can't. And the reason for that is a subject for another video. What I do want to do is look at how would we find this average speed when there's seemingly not enough information. So we're going to take that piece that you think you need to know. First of all, let's just start off by saying that what I'm going to be looking for is I'm going to be looking for the time for the first half, which I'll call time 1, plus the time for the second half, which we'll call T2, and that should equal the total time. So the time for the first half, if we look at distance equals rate times time, so look at distance equals rate times time, which of course you know, so the time is equal to the distance over the rate. Now I'm going to take this distance over the rate, which is 36, plus the same distance for the second half over the rate s that we are looking for, and that needs to equal the total time, which is going to be the total distance, 2d, over the rate, and the rate for the whole trip, the average rate that we're looking for, is 45 miles per hour. And we want to solve this for s. Now you may say, but there are two variables, and we're not going to be able to solve for the single variable. But in fact, we can. And if you just simply think about doing this, can I multiply both sides by 1 over d? Yes, I can. I'm using a property of equality to do that. And then what's going to happen? On the left side, I'm going to have 1 over 36 plus 1 over s is equal to 2 over 45. And now I've got an equation in a single variable that I can solve for. So it's as easy as that to find the average speed. And there is enough information, and we will get a different speed than if we had tried to use this erroneous equation.